So here I'm going to start out with a worksheet that is very common to Algebra 1 courses in which students are solving equations. Typically, the teacher demonstrates the properties of equality to solve the equations during a few in-class examples, and then the students are left to complete the 20-problem assignment that mimic what the teacher did in class. Students are often successful in finding the solutions if they followed along with the in-class examples, but instruction is limited with this model that we all know too well. Is this model truly engaging the students? As math teachers, we often are challenged with time constraints that limit our ability to cover the entire course curriculum in depth. As a result, instruction becomes direct and procedural. Although we'd like to provide opportunities for students to discover mathematical concepts and apply their understandings, we simply must cover too many topics. This practice of direct and procedural instruction allows us to cover all the material in our textbooks, and students are able to memorize procedures and calculate correct answers on end-of-chapter tests. However, true conceptual understanding and application skills fall short or non-existent. When the skills are needed at a later time in the textbook, students struggle to remember what they learned in preceding chapters.
Kelly, there's a question.
Okay.
Sendil asks, a question that comes up with the old way is who's doing the mathematical work in this lesson?
So pretty well the teacher. It's very teacher-centered instruction.
Yeah. And I'll unmute Sendil in case. Sendil, did you want to follow up on that question?
No, it was just a thought. Thanks, George.
No. Oh, thank you. Okay.
So this year, when I introduced equations to my Math 1 students, I began with a discussion about buying a car because most of my students would be obtaining a driver's license in the next year or two. I asked the students if they had started saving for a car yet, and one student had already saved $1,000. Then we discussed jobs that students their age could obtain and what the hourly pay might be. One student was working for $8 an hour. I asked if that amount was take-home pay or if there was any amount that would be deducted. He said he usually loses about 20% to taxes, and the students calculated those taxes to be $1.60 per hour. Then I asked what kind of car the student would like to buy and how much the car would cost. One student found an SUV that cost $18,000. My next question was, how many hours would you have to work at $8 per hour to earn enough money to buy that car by your 16th birthday if you've already saved $1,000? We began building an expression to represent money saved. As we built the expression, we discussed each piece using math vocabulary. The variable h would represent the number of hours needed to be worked. 8h would be the term that represents amount earned each hour. But students remembered about the 20%, and they had to deduct $1.60 per hour. So they put this into the expression as minus 1.6h. We discussed 8 and 1.6 as coefficients. Students added on a constant of $1,000 to the expression to represent the amount they already saved. I added that the students went over on their data package this month $100, so they must pay back their parents. This was included in the expression as a constant as well, minus 100. I informed the class that their parents were feeling very generous and decided to double the amount saved at their 16th birthday as a gift. Students advised me that I needed to multiply by 2. I asked if I should multiply by 2 or just multiply the 2h by 2. They replied that I would need to put parentheses around the entire expression, then multiply by 2. They wanted the parents to double everything, not just the 8h. Finally, this amount must equal $18,000 to afford the car. Our equation was complete. This discussion lasted the entire class period, and this was our first day in equations. So through this discussion, our students gained real-life usage for equations, and vocabulary was highlighted in context. As my students left the classroom that day, I overheard one of them tell his friend, "This class is going to be so much fun." I was ecstatic because this is not something we often hear in a math classroom. Throughout the unit, we would refer back to this problem when discussing problems about solving equations. And by the end of the unit, students calculated the number of hours they needed to work to afford the vehicle. And they found out real quick they're not going to be able to afford this $18,000 vehicle in the next year. As a result, I found my students using the math vocabulary and writing equations to solve real-world problems with little hesitation. My math department recently made the decision to revise our curriculum to follow the new Illinois Learning Standards Integrated Math Pathway. Today, I'd like to share more of my experiences teaching Integrated Math 1 and using resources from the Illinois Model Math Curriculum. So, why did we make the switch? First off, our Algebra 1 student achievement was down, and we were unhappy with significant failure rates in Algebra 1. Sometimes one class might even have 80% as high in their failures. So students were not interested in the curriculum and didn't find it relevant to their lives. We didn't have enough time to teach the depth of the course content and still cover the book. So then the students weren't ready for the next year's content. As a result, we found ourselves reteaching key concepts from course to course and never really gaining the student mastery that we intended. After careful investigation, we determined integrated math would allow us to teach less major topics per year, and in turn, students would learn in much greater depth. We were relieved to see that ISB was providing a scope and sequence and model curriculum for the integrated pathway. No need for us to reinvent the wheel. Further, integrated math uses Algebra 1 and geometry topics to enhance each other, and this is how prior grades are already teaching mathematics, so we felt this transition was more appropriate for our students. So here's our implementation schedule. 2014-2015 school year, we began teaching Math 1 to incoming freshmen and students that had previously been unsuccessful in Algebra 1. Planning for the course began last year, 2013-2014, and we had about 1 day per month where our department was given a plan. We all got subs and we had planning time. We met as a department several days during the summer of 2014 as well. 2015-2016 school year, we will add Math 2 to our curriculum. We're currently in that planning process. And then 2016-2017, we'll complete this series by adding Math 3. So what's different? Right here you see our former Algebra 1 sequence. This was our daily guide, pacing guide that we would follow. In red, I'm now showing you what our Math 1 year looks like. So we've crossed out all of those additional topics that are now being taught before the students are in Math 1 or after. A big topic that is being deleted for right now is our freshman curriculum is quadratics. That's moved to Math 2. As you can see, we are teaching a lot less topics. Our freshman curriculum went on that diet that we've been hearing about. This streamlining of our curriculum allows us to define the focus of the course. In our former traditional sequence, we followed our Algebra 1 textbook covering 14 chapters. In this plan, chapters were divided into bite-sized pieces of content, which we would only have about 1 to 2 days for each topic. The division of these concepts, for example, with equations, we first taught 1 step, followed by 2 step, multi-step, variables on both sides. This led to a more procedural type instruction. When the problems look like this, you do this. After the steps were mastered, we would throw in a word problem or two in which we would find our students would either skip or just respond IDK or I don't know. Now our scope and sequence contains 10 units. Concepts are introduced from day 1 through real-world context. Students now extend over an entire week. Sometimes two lessons now extend over an entire week, sometimes 2 instead of just 1 or 2 days. Less topics has allowed us to spend more time time on the topics we're teaching, and no more mile wide, inch deep. So now we have no textbook. Instead, we follow the Illinois State Board of Education model math curriculum. This has allowed us freedom from teaching page to page in our textbook. Now we're able to use materials from the model curriculum, and we feel confident in creating our own materials to meet the specific needs of our students. Sometimes we modify the model curriculum as well. We have time to implement these activities, and they're fun and provide relevancy to our students' lives. Some would consider the idea of having no textbook to follow a major challenge. My reply is yes, it does involve a lot of extra planning time, but once I see the way my students positively respond to the activities, I know it's worth the time investment. On this slide, you'll see the Grade 8 and Math 1 scope and sequence from ISB LiveBinder. Now our curriculum builds in a coherent manner within the course and from one grade to the next. We are taking the skills they learned in previous courses and pushing students deeper into that content. In Grade 8, students solve linear equations in one variable, which leads to deeper work with solving linear equations in Math 1 Unit 1. In Grade 8, students use transformations to understand congruence and similarity and discuss parallel lines cut by a transversal. This unit leads into Math 1 Geometry Unit, where students use rigid motions to discuss congruence of angles and prove theorems about parallel lines, triangles, and quadrilaterals. In Grade 8, Unit 4, titled Functions, this involves proportional relations, functional relationships, and discussion of slope and linear functions. This sets students up for more depth work with functions in Math 1 Units 3 and 4, and work with linear functions in Math 1 Units 5 and 6. Grade 8 Unit 5, titled Linear Systems, involves solving linear systems algebraically. Students extend this knowledge in Math 1 and understand the solution as the intersection of the graphs of two linear functions. They're able to write a system of equations to solve real-life problems. Grade 8 Unit 8 involves work with scatter plots, line of best fit, interpreting slope, and two-way frequency tables. This builds a foundation for Math 1 linear modeling and statistics units. The other unmentioned units are essential for further use and extension in Math 2 and 3. When we were choosing the path to implement the new Illinois Learning Standards, we did not find the same coherence between our Grade 8 curriculum and our former Algebra 1 curriculum. We are no longer information givers and procedure showers. Countless days of presenting steps at the board are no more. We're now facilitating learning. We're having discussions with students in our classrooms. We present students with scenarios and let them sort through the problems and ask the questions before just telling them how to think. Students are no longer asking us, when will I ever use this? We are offering them real-world scenarios from day one, and they are contributing additional context in which the material is relevant to their lives. Math 1 is not limited to teaching procedures to get answers. It involves more rigorous activities and assessments to provide students with experiences that balance conceptual, procedural, application levels of learning. In this activity that you see, it's from the Illinois Model Math Curriculum. Students are stacking cups and measuring the height. They're recording this data. They plot this data and analyze the pattern. Then they make use of their knowledge about linear functions and write an equation for a line of best fit. We are no longer just giving them some arbitrary data. Now they're collecting it themselves and seeing the significance of the data in real-world application. This process includes all learners and hooks those that are not our typical math lovers. The task continues by discussing the story behind the data. Students discover that as the cups increase, the height increases. They're asked to explain the constraints and slope. They discuss the key features of the graph and explain the variables in context. Then, using the line of best fit, they make predictions about how many cups would be used to reach the top of the Willis Tower. So at this moment in the lesson, I pause, I pull up a picture on my projector of the Willis Tower, and we talk about students that have actually been up top in the sky deck. And those that haven't, now they see how tall this building really is. So they can actually get that visual representation of what their algebraic solution really means. Okay, this goes above and beyond the procedural tasks that we saw in traditional courses. And students are excited to do this math because they're part of the process and can see that real-world connection. Another comparison of the changes in rigor include these quiz samples. We can all recognize the basic procedural quiz on the left from Algebra 1, which this is our former Algebra 1 quiz. But take a look at how it differs from our new Math 1 quiz on the right. The Math 1 quiz requires students to write a system of equations from a real-world situation. They graph the system and discuss the explanation of the solution. Algebra 1 students often question why they're even doing the processes of substitution and elimination on the left. They don't recognize the real-life use for that algebraic procedure. However, by presenting the context through these real-life uses to our Math 1 students this year, we heard no criticism of the math involved. Our Math 1 students are not afraid of word problems. They aren't leaving word problems blank or writing IDK on their tests and quizzes. We don't hear, "I don't do word problems" from integrated Math 1 students. Their entire tests are full of word problems or problems in context, and our students are attempting to find all of the solutions. And additionally, the quiz on the left no longer falls in the scope and sequence of high school standards. These tasks can be found in the grade 8 curriculum. If we would have continued following our old Algebra 1 curriculum, we would be reteaching concepts and spending that extra time on concepts that are no longer part of our grade level. Here's an additional task involving systems of linear equations and inequalities from the Illinois Model Math Curriculum, Unit 7, Summative Assessment. This task ensures students are recognizing situations in multiple representations. Students must match the graph with the story and the equation. This task ensures our students have a much deeper understanding of linear inequalities than our typical Algebra 1 procedural tasks that we found in our former curriculum. A focus in Math 1 is using appropriate mathematics vocabulary. Since we emphasize this vocab, we have noticed Math 1 students of all levels using it in their discussions. When completing another multiple representations task this year, one of my students that was holding the y=7 card was overheard asking his peers, "So who has the constant function y=7? And by the way, this was a student with an IEP. So he's asking, who has the constant function? In this functions unit, students were describing functions as increasing, decreasing, and constant. They also recognized vertical lines as relations that were not functions. So they continued using this terminology as descriptors when discussing linear functions. As we enter the geometry unit, we use an activity provided by the Illinois Model Math Curriculum from Unit 2, Lesson 1. It was titled Secrets of the Transformation Society. In this activity, students act as undercover agents to complete an investigation about transformations. The activity provides detailed directions for using interactive geometry software to complete transformations in the coordinate plane and analyze angle measure and side length. Unfortunately, our access to the computer lab this year was limited, so instead we posted these pictures around the room as a modification. The pictures were created from the directions that were provided by the model curriculum and then printed out on paper. We hung them on the walls. Students followed the series of clues from the activity and completed the student daily logs that were also provided by the model curriculum to summarize that translations, reflections, and rotations preserve congruence, while dilations produce similar figures. This activity was very fun, and my student teacher and I discussed that the students were more likely to learn the goal of the activity because they discovered it on their own instead of a teacher telling them and asking them to remember. Another one of my favorite Illinois Model Curriculum tasks that I use this year is also from Unit 2. This task is from Lesson 2 titled Build Your Own City. Here, students act as a mayor designing a city. The guidelines include a list of must-haves. For example, the city must have at least 5 parallel streets and 4 stop signs at vertical angles. But the city is not limited to these items. Traditionally, the work from my geometry textbook involving parallel lines, transversals, corresponding angles, vertical angles, and the like included tasks that asked students to identify the angles or find missing angle measures. The problems in the book are quite procedural. This task allows students to demonstrate mastery of the material in a different way. It goes beyond right or wrong and allows students to be creative. Make note of the item that requires a student to place a shopping center that is at a supplementary angle with a movie theater. Some students place these landmarks as linear pairs, others at same-side interior or exterior angles, and others at 2 right angles, all being correct placements, yet varying in interpretation of the guideline. So student engagement has increased drastically in our classrooms. Kids that don't get math are not zoning out or falling asleep in class. They are active participants in this learning environment. Students feel safe to give the activities a try because we provide experiences that, to quote Dan Meyer, invite all the kids to this country club that is math. In the buying a car discussion mentioned earlier, all students could contribute to the conversation about buying that car. Writing and solving equations and developing math vocabulary was at the root of the activity, but all students, not just the strong math students, were heavily engaged. Once they were hooked, they were ready to persevere in solving the problem, which highlights our math practice standard number 1. Additionally, using the engaging activities prevents teachers from just lecturing the entire period and provides teachers more time to walk around the room and observe students. We are more quick to recognize a struggling student and intervene before the student becomes disinterested or, worst case scenario, gets left behind. Students are helping students too. I often observe them comparing and critiquing each other's work, which meets our math practice standard number 3. Students' attitudes about math class are changing as well. We aren't hearing things like, when am I ever going to use this? Or, I hate math. Now we're hearing kids say things like, this is fun, and I don't dread coming to math class anymore. Instead of asking, can we have a free day? They're asking things like, what are we learning today? Students are smiling instead of looking frazzled and bummed out. We're completing more rich tasks with these students than ever, and they're not feeling overwhelmed. I've also found that grading is less intense in my Math 1 course. Since a lot of these activities are performed in the classroom, I'm completing more observational checklists like the one shown here from the Illinois Model Curriculum. I'm not always waiting to find out what students know the day after presenting material by grading 20 problems that I assigned for homework at the end of the period the day before, or waiting to see what students know on a summative assessment at the end of the unit when it is too late to change the outcome. My observations are more immediate, and I'm able to provide interventions more timely. There are less formal grades in the gradebook, but I feel I have a better handle on what each individual student knows each day before they leave the classroom. I can spend more time in the evening creating innovative lessons to go along with the model curriculum because I'm not swamped grading daily homework assignments. Overall, I feel that my role in the classroom has evolved more toward facilitating learning and less focused on grade assigning. So what else is different? We have our student achievement is on the rise. At times, we would see our Algebra 1 failures outnumber those that passed the course. This school year, we checked at the end of first semester, and the failures were less than 10% for Math 1 courses. Most of those that did fall into that small percentage were due to chronic absences, which we're trying to work on fixing that as well. Further, students repeating the course credit after failing Algebra 1 the previous year were also proving more successful with Math 1 curriculum. Some students in that class were quoted, "Why couldn't we have learned like this last year?" So what does the model curriculum, the Illinois model curriculum, have to offer teachers? You've already seen the scope and sequence provided at the beginning of the presentation, so I'll discuss additional resources available and resources that we've found very helpful to use. To inform families about the course, family letters have been provided. We sent this letter home the first day of school. We felt it was a great tool to explain the course content for the year since our students would not be following a textbook. We wanted families to be informed that we were following the Illinois Math Model curriculum and not simply making the topics up. We felt it was important to inform families of our coherent plan that aligns to the new Illinois learning standards. Okay, the model curriculum also offers a unit map for each unit. In my opinion, this document is the most valuable tool when planning a unit. It is a must-read by all teachers. And I say that very strongly. The teachers must read the unit map. Okay? You won't know what's going on in the unit if you don't read the unit map. So read the unit map. This document begins by providing teachers with connections to previous learning, the focus of the unit, and connections to future learning. Then related portions of the document, progression documents, are cited so teachers can further read about this, how the students will progress in the unit appropriate domain throughout the rest of the math curriculum, and then also see how they have been progressing. Following the progressions document portion are the standards for the unit. Those highlighted in green are the major standards, blue, supporting standards, and if you see any in yellow, those are additional standards. Further, student understandings from the unit are listed to help teachers break down the standards into student learning targets. A transfer section is provided to explain how students might apply the concepts throughout the unit. Essential questions are listed as well. Mathematical practices emphasized in the unit are indicated with an asterisk, and there's a brief summary of how the practices connect to the content standards in the unit. This is another great tool for teachers that need an idea or other ideas for those tasks. Prerequisite skills and advanced skills are listed for teachers to think about pre-assessing prior knowledge and to consider enrichment activities as well. Statements of what students will know and be able to do are provided. It's a good idea to copy these lists for your students at the beginning of the unit. Then they can refer to this list throughout the unit to make sure they're on track, or use it at the end of the unit to make sure they're prepared for the summative assessment. Further, ELL benefits are stated, and unit vocabulary lists are available. And finally, the list of lessons and assessments created by the Model Math Curriculum team are present. So teachers know what type of assessments are available to them and the sequence the assessments will be utilized. At the beginning of each unit, if you get on the Illinois State Board of Education Live Binder, you'll see a tab in each unit as well for a family letter. So this is different than the family letter from the beginning of the year. This one's specific to the unit, and then in this case this is Unit 1. It can be sent home again at the beginning of the unit to inform families of the expected outcomes of the unit. The letter defines the focus of the unit, the practice standard expectations, sample tasks, future application of the unit, and ways in which parents or guardians can help their students at home.
Kelly, may I ask a question on this? Can you tell me what
Yes.
kind of responses you've gotten to that letter? Do parents have parents commented on it?
We haven't had a lot of parents comment on it, but honestly I feel that we really also haven't had any questions about not following a textbook either. So I think that they're kind of doing the job there.
And while I've interrupted you, I'll ask another question that came through, or a couple. How many teachers and how many students are involved in this at Murfreesboro High School?
We have 5 teachers teaching this, so it does get a little at times difficult for all of us. We try to stay on the same pace, so making sure 5 teachers are understanding everything.
And are they all 5 in Math 1 or some in Math 2? And
only Math 1 this year.
only Math 1, okay.
And we have, I think, 7 sections of Math 1, class size averaging between 15 to 20.
And are there common assessments? And if so, at what grain size? The course, the semester, the unit, lesson?
Well, we all give the same unit final assessment. So at the end of the unit, we'll give the same assessment. And then a lot of times our quizzes will be the same as well.
Okay. All right. That's it.
Okay.
I'll let you get back to your presentation.
Okay, so another resource that's available through the model curriculum is a lesson plan. And the lesson plan, sometimes there's more than one lesson plan. In this unit there's actually one, and it says up in the corner lesson 1 of 1. So the first unit has the lesson plan, which offers us targeted standards and practice standards. They give us lesson procedure, or the purpose of it, an explanation of rigor, explaining tasks that involve the conceptual, procedural, and application understandings. They give us vocabulary, evidence of learning, with description of either pre-assessment, self-assessment, formative, or summative. And then they give us a lesson sequence, which again, this also is a document that you must read to make sure that you understand how the assessments that were created should be utilized. I know it's easy for people just to jump straight to the documents, but it is helpful to read the unit map and these lesson plans so you can kind of see how the team planned the unit to look. So each segment of the lesson defines suggested time frame, a focus, a lesson format, required resources, modality representations, potential pitfalls, differentiation suggestions, independent practice, and then the steps for executing the lesson. And then here I've got some examples. Since I was showing you Unit 1, I just pulled some examples or pieces from the model curriculum, from the documents that were provided. This one being a self-assessment, a radar for the beginning. It's a pre-assessment for this unit where students kind of rank themselves on where they're at with the vocabulary. So teachers can use this type of assessment to determine if reteaching of any grade 8 standards must occur, or if students are ready just to move on into the Math 1 standards. And these pre-assessments are especially useful, as we know there will be some holes in the curriculum for the next few years as we begin implementing the new Illinois Learning Standards.
And Kelly?
This activity from Unit 1 was titled Listen.
Another question came through.
Okay.
Is the map activity that you shared your own, or are you willing to share it?
The map?
Yeah, I think that refers to the city.
Build the City?
Yeah.
That one is actually available on the State Board Live Binder.
Okay. Thank you.
Yeah, that was from Unit 2 of Math 1. Okay, so this activity here is from the Let's Investigate, and this is also from the model curriculum. It requires students to justify steps in solving inequalities. So here they're not just solving them, they're actually justifying. And then they compare solving inequalities with solving compound inequalities. And the verdict is, follows that last assessment in Unit 1. And I'm just taking snippings from these assessments. There are more tasks involved on them. But this one requires students to compare the work of two students and construct viable arguments supporting the correct solution. This is another example of Math Practice 3 within the model curriculum. Here's an example from Unit 1 where students create their own inequality to represent a real-world situation. Then they provide the solution correctly and incorrectly in a sample discussion. Then this activity was planned to be exchanged with a partner the following day for critiquing. Again, we see students allowed an opportunity to come up with their own way of demonstrating the mastery, and then also practicing that math practice number 3 where they can critique the work of others. These items are from the summative assessment from the model math curriculum for Unit 1, and they provide different examples of levels of learning. Notice in this task, students must describe the variable, describe the discount represented in the expression, and then explain the entire expression in context. In this item, students explain similarities and differences between the equation and the inequality. Then they support the explanation with a word problem that illustrates the equation and the inequality. So again, they're coming up with the context to the equation and inequality, not asking the question, why would I ever use this? They're demonstrating that they know where these would be used. And then here's another one where they're given a scenario and they have to write an equation to represent. They have to explain the parts of their equation, and then they have to solve and justify their answer. And then you may ask, where do you find the ISB Model Math Curriculum? One way is to approach this Illinois State Board of Education website, and you can find underneath the math, ISB Model Math Curriculum units can be found here. Here's a link to the model curriculum. And then I want to discuss our claims for supporting our integrated Math 1. We've noticed that there's more time to teach less topics.
Yeah, there are a few questions that have come in, and maybe this is a good point to get at them. How do you help students who lack many basic skills? A teacher remarks that she finds herself has to stop teaching a lesson because there are so many skills that students are missing.
One way that whenever I find in the middle of a class discussion that someone is lacking the skills they need, I think it's a good point where we discuss within the classroom if anyone understands those skills or still has those skills so that they can explain the procedure or the concept to the other students. A good way for them to learn from each other. Sometimes if I notice it's just one individual student, we have a time 30-minute class period called it's an extended learning period where I will invite that student to come in for math tutoring with me during that time.
Okay, but is it safe to say that peer tutoring is a common thing that you use, common way you use to get kids up to speed?
Absolutely.
Are the elementary and middle schools also using the model curriculum?
Yes.
Okay. Okay. And how long have they been using it?
I know our 8th grade, and I'm not as sure about our lower level, but I know coming in before us, our 8th grade teachers definitely used the scope and sequence last year as their first year. So they're working on their 2nd year of following the model curriculum.
Okay. Is the model math curriculum something that tells teachers what to do every day, or a starting point for teachers to collaborate and design units for lessons?
It is not an entire curriculum. It is just a starting point. Okay, we found once you start looking through some of the things they made, it gives us new ideas to come up with. We've been able, like I said before, now we have confidence to write our own material to go along with the standards. After we see some samples that are available to us, we're able to come up with more for day-to-day instruction. But no, it is not a full curriculum.
And you were on the writing committee for some of this. Is there a network of people using the model math curriculum as well as those who were involved in writing it?
In my region, we have a network in Southern Illinois that we work together as a cohort, but I don't know necessarily if there's one across the state.
Okay.
Besides just using, I think the supports and using the live binder is sort of the network.
Okay, thank you very much. To those of you that ask questions, if they didn't get answered, if you'd put them in again, I'll try again to ask Kelly. Okay, so back to you, Kelly.
Okay, so we found again more time to teach less topics, more coherent vertical alignment, which does become an easier transition for our students coming in to high school, which we've also proven that it has been easier for them because we have less failures that freshman year. Students are more engaged. Students enjoy math now. Students are problem solvers, not just problem doers. Students are using math vocabulary. And not just the students are having fun, but we are having more fun teaching. And there's more student success. Okay, so additional questions?
So if you have additional questions and you would like to put your hand up, I can unmute you. Also, I see some coming in on the question text. So I'll start with those that are on the question text. Could you say more about how grading works? Also, well, I'll start with that and then we'll get to the also.
Okay, grading, formerly I used to grade every single day. I would send home an assignment every day and grade that assignment, that homework assignment. I don't have homework every night anymore. A lot of times what I do is I'm gauging if my students are learning by actually walking around the room and talking with the students, using those observational checklists to know, yes, my student has met this standard, or no, not quite yet, and I don't need to send home 25 homework problems to find that out and kind of lead where my instruction goes the next day. Instead, I can just immediately talk with them because I have time instead of just lecturing.
So
when I do collect, oh, go ahead.
I was going to say, so was there a change in grading policy related to the model curriculum, or how are grading and the model curriculum related?
We didn't necessarily have a grading policy change. I just think the activities sort of lend themselves not to having as much grading at night.
And is there standards-based grading in your school? It doesn't sound like that approach was
no,
part of it.
We haven't adopted standards-based grading at this time.
Another question is, how would you recommend that districts begin something like this? How do you start?
I say you start at the Illinois State Board of Education live binder for the model curriculum, and you begin that scope and sequence. If nothing else, follow those units. You have to read the unit plans. Those maps are imperative for your success and understanding, because I think a lot of times the titles, we just read systems of equations as high school teachers, and if we read that from the scope and sequence, we might think that we are teaching substitution, elimination now, but really we have to kind of even go backwards too and read the standards of the grade before us and realize that that's actually 8th grade now.
And this is a question for me, really. It seems to me that teachers might need someone to reach out to if they were trying it the first time. My feeling is that you, Kelly, were part of a group of people working on this, so maybe it was easier for you to get started, or maybe not. I don't know, but it feels like if there's somebody out there that you know that you can reach out to, would you recommend that, or do you think people can pick up the live binder and just do it?
I think if you read the resources, I mean, definitely there's still some times where I may even have a question. You can also sign up to be a pilot school where you pilot and sort of have direct contact with the actual team, giving them feedback and things that you maybe weren't clear to you, so that they can change maybe some directions in their unit map or lesson plans. But anyone can contact me if they had questions, and I think most of the team, hopefully, that we plan on getting out there eventually. I think as this project progresses, hopefully get some more professional development going.
Another question, are students and parents okay with not having homework every night?
Again, unfortunately, I haven't heard a lot of feedback from my parents, which I don't know if that's a good or a bad thing, but my students absolutely love it. And I feel that my students understand the concepts more, even though they're not just working 25 problems at night. Yeah. They're getting those more rich experiences in class.
Do you feel they're better prepared for the park?
I do. A lot of the model curriculum activities lend to park-type questions, so we also try, when we write our own additional curriculum, that it goes along with that as well.
Okay. I believe those are all the questions that I see. I'll say to the group again, if you put your hand up, I can call on your microphone, or if you type in another question, I can read it to Kelly. But I think that's all the questions. I think that's all the questions that I've seen right now. Anyone else? Give a little wait time. How many people are on the team?
Well, on the Math 1 team, we have 4.
Okay. I'm gonna pick on Jenny. She asked that question. You mean, is that what you meant, Jenny? How many on the Math 1 team?
No, that sounds like right.
Okay.
Just wanted her to clarify that it's not 50 people working on this. It's only a few people, and look at what they can do.
Okay. And actually, while I have you on there, Jenny, can I ask you that question that I asked Kelly about a network of people to support? If other people want to sort of join in, is there a group that they could? What's the best way?
Probably the best way is to contact me. I do know that Our model curriculum team members obviously are users of the model curriculum, and there are several districts. In my area, we've got kind of a users network in my county, and it kind of goes beyond my county, where we get together 3 times a year and we meet by grade level and by course to talk about what's coming out in the model curriculum and the successes and the struggles that everybody's had. And I know that those kind of networks are formed, around the state. That is one of the things that ISB is hoping to do, is to do more PD and to do more networking moving into next year. That's kind of the push for next year, is the PD.
Okay. And for people who may be watching the video or listening to the video, or watching the video and listening to this, I'll note that this was Jenny Winters, who's been a key organizer in all of this, that just answered that question. So, and I don't see any other questions coming in. So if that's it, I thank you, Kelly, for doing this. We've recorded the session, and I'll put it up on the ICTM Media website.
Thank you.